In this video, our objective is to learn how to construct a box plot. The data set we will use reflects weekly pay of 24 randomly selected employees. And those 24 data points are reflected in 4 rows and 6 columns as depicted. In order to construct a box plot, step 1 is to find the median. When you have 24 data points, the median is the 12th position in the array and the 13th position in the array added together and divided by 2. So basically we're going to find the average of this number, and let me start with the parentheses, 890 plus 960 divided by 2, and that's 925. Once we have the median, then we can calculate quartile 1 and quartile 3. In order to calculate quartile 1 essentially is the median of these first 2 rows of data that reflect the weekly pay on the lower end of the scale. So the median of the lower half of data here is the average of the number in position 6 in the array plus position 7, the number in position 7 divided by 2. Okay, so it's this number, and we'll make that a different color, and this number, okay, and the average is 750. And similarly, to calculate quartile 3, it's the number in position 18, and again, we'll just use that same color, and position 19, because we're looking for the median of these last 2 rows of 6 numbers each. So quartile 3 is equal to the average of 1200 and 1200 and 1260 divided by 2. Okay, so now let's put these numbers on the box plot. So we have 750, we have 925, and we have 1230. Okay, and so basically the 750 lines up pretty well right here with this vertical line. 925 goes with this vertical line, and then 1230 goes with this vertical line. The next step in the process, we need to calculate the interquartile range, IQR, defined as Q3 minus Q1. Well, we know what Q3 is, we know what Q1 is, so it's a simple equals 1230 minus 750. 480 is the interquartile range. The next step is we need to multiply this number by a factor of 1.5, and so it'll be equal 1.5 times 480, which is 720. Now, next step, we need to calculate the upper and lower fence. The equation to calculate the upper fence is the quartile 3 value plus this 1.5 times IQR. So let's just calculate that. Here's quartile 3 plus this 1.5 times IQR, 720. That equals 1950. Let's do the same thing for the lower fence. That equals Q1 minus 1.5 times the interquartile range, and that equals Q1 minus 720, and that gives us a number of 30. Okay, now we don't plot the fences, if you will, on the box plot. The way we use the fences is, let's start with this 1950. So we want to look and see, where does 1950 fall on the upper end of this data array? Well, 1950 falls between 1820 and 2080. Okay, so the fact that these 3 numbers, 2080, 2300, and 2400, are larger than 1950, that makes them outliers, okay? So we're going to put 3 asterisks here, and it's going to be 2080, comma, 2300, comma, 2400. These are outliers. Over this whisker, we want the largest data point that isn't an outlier. Well, the largest data point that isn't an outlier is 1820, and that goes right here. Okay? On the lower end, the lower fence is 30, which is way smaller than the lowest number in the data set. So over this whisker, the smallest data point that isn't an outlier is 540. Okay, so 540 lines up with this whisker. So this completes this video of how to construct a box plot. We use this array of 24 data points. We calculated quartile 1, the median, quartile 3. We reflected those 3 numbers as such here. And then we calculated these parameters, and we used our fences to determine the largest data point that isn't an outlier and the smallest data point that isn't an outlier. That concludes this video.